Good morning and welcome to part 5 of Online Math Thinking Fundamentals, a series where we learn how to learn like a mathematician. Today's topic is shape. Now, hold the phone right there. I'm not going to dig into all of geometry here and talk about hexagons and pentagons and different kinds of shapes. What I'm referring to is the shape of a number. Yes, numbers themselves can have their very own shape. So, for example, let's start off with our favorite number 4 from earlier. What shape comes to mind when I say 4? I would hope most of you think of a square. And the reason a square best resembles 4, or 4 best resembles a square, is not just because it has 4 sides, but because 4, right, is 2 squared, right? Same reason that we would say 9 is a square number. You can use, well, we say it's a square number. It is something squared. We use that term. So to think of it in terms of the shape square makes perfect sense, okay? But there's more to it than that. It's a way of visually thinking about numbers. I want you to think back to the number line, right? You've more than likely seen this before. Here is 0, and then we could 1, 2, 3, -1, -2, -3, right? Plot them on the number line. And in that sense, any number of ours, the number 2 here, is not just an amount of things. It is referring to a distance from 0. And if you were to take, say, -3, right, that is also a distance from 0, but in the opposite direction. So now we've got both a magnitude and a direction. Sounds like vectors, right? Get another word. But a very useful visual tool. So another way to start thinking about numbers and mathematics that will help you going forward is to consider the shape of numbers. How can I visually represent this number? And the first thing is distance from 0. Of course, we can expand upon that with our good old Cartesian plane, right? And this is just 2 perpendicular number lines. But that allows us even more possibility because we can represent any position in seemingly any direction in a 2-dimensional plane. Right, let me just fill this in based on a horizontal and a vertical component, right? You create that 90-degree triangle in there, and now we're looking at Pythagorean theorem, right? You may remember this: a squared plus b squared equals c squared. So this distance here away from 0 is, yes, it's a magnitude, it's a number, okay? It can be whatever, 25, and it will correspond to these other 2 numbers there. So go back to day 1 in your web, your thought web map of ideas. To every number, there connects these Pythagorean components, as it were. Not necessarily every number. There's the Pythagorean triples that work for nice integers. We want to leave fractions out of it for the time being. But every number can be a distance from 0, a location in the plane, and then of course we could go, really crazy and get in a right, a z-axis direction there, and then we plot our point up here, and it exists in space, and we go down, and it sits right there, and it's actually you got to visualize with me here, right? So we're building up a cube. Right, one corner here. Here's the base, the bottom of the cube, and then we go up this tall, right? Into 3-dimensional now. 3D space, a coordinate, and a position in that space, right? Like, I work with the camera here, right? We can have a flat plane, right? And then we can move up, and there's the corner, right? Think of numbers in terms of spatial reasoning. That will unlock a lot of powerful tools down the line. One of them being, well, I'm going on to the second page here. How many of you are familiar with the imaginary numbers? Again, here's our number line. And then perpendicular to that, we put the imaginary numbers. 0, negative I, and so now we create the complex plane. And this, it turns out, is really useful for electronics. They work this way because imaginary numbers have some differing properties to them. They're kind of halfway between positive and negative. So instead of just taking two regular number lines and creating our Cartesian plane, saying, what if we had an effect that wasn't quite positive, negative, polar opposites? We wanted a halfway point so that you kind of rotate between the three of them. And if you want a little bit better, further explanation on that, I invite you to go to the website betterexplained.com. There's an excellent page about an intuitive understanding of negative numbers, not negatives, imaginary numbers, based on this concept here. But what it allows us to do, right, is think of numbers as a new dimension, right? It's unlocking a whole nother layer, a whole nother way of thinking about things. Before we had negative numbers, that you think historically here, we started with counting 1, 2, 3, 4, 5, and it wasn't until later that it developed. Hey, what about like debt? What if I'm missing 2 sticks? I know I had them, but now they're not here. That's a negative 2 sticks, right? I am owed 2 sticks. I'm missing that. That negative number concept comes into play. And so that unlocks a lot of very powerful tools, right? We use negative numbers all the time, especially talking about economics, one of the number one reasons for doing math. Right? Imaginary numbers allowed us to do the same thing. It unlocked another path forward, or not forward, not backward, in another direction, right? A new direction in which we could travel and explore and use numbers to meet our own ends. And it turns out they became really especially useful in electronics and engineering, that kind of field. One other fairly obvious example of visualization of the numbers themselves. Let's go back to the Cartesian plane, because I want to make sure I draw everything out explicitly here. Not just a single point there, and we can Pythagorean theorem and distance and all that good stuff, but many points, right? Creating a graph, a curve, some plot, right? This is a mathematician's way of visualizing not just one number, but a whole set of numbers, a whole series, sequence, what have you, of numbers. Lots of them together that create some kind of a picture, right? As a visual component, you can now see what story is being told by those numbers. So once again, the visual, not just for a single number, but for many numbers, plays an even larger role, and we use the graph in everything now. That's why it's so critical that you learn them in school. I would say not so much graphing them by hand. We have computers to do that now. It takes a lot of the tedious work out of it. But you want to be able to read them and understand and represent and see what all is being said by that graph. There's a lot going on here. The fact that it's increasing, that it decreases, that it changes, it curves up and down and swims around. All of that tells a story, right? To borrow an English phrase, picture is worth 1,000 words. I'm sorry, I've got to get used to, my screen is over there. You see the visual up that way. So, right, picture is worth 1,000 words. There's a lot more words there. And it's way easier for a human brain to interpret visual elements than if I just gave you the list of numbers, just the points that make up that graph. You don't see, well, let's see what I did there, the pattern nearly as well as a visual element. So just another reason why it is so important to think of numbers in a visual manner. That's really all I want to draw your attention to today. Try to think visually even when it's not immediately apparent that there is a visual element. You've got to add the visual part to the numbers, and it will help you move along. That's going to be it for today. So long, farewell, enjoy the rest of your day.